Well, we have a couple of equations to graph. Let's deal with the first one. 1. F of x equals 3 times the absolute value of x plus 1 minus 3. Now, what we find in here, x plus 1, that expression has to do with a horizontal transformation. This term that's independent, minus 3, has to do with a vertical transformation. So let's consider what the graph of y equals absolute value of x looks like. And here it is. And if x is 1, we get 1. If x is 2, we get 2. If x is 0, we get 0. If x is negative 1, we get 1. If x is negative 2, we get 2. And you can see that looks like a V. And whenever we graph an absolute value function, that will be the general form. It might open up or down, but otherwise that will be the form. Now, we'll take this point. What value of x takes this to 0? Well, 0 does. Now let's consider this, the graph of this equation. And what value of x, ignoring the negative 3, takes this expression to 0? Negative 1 does. So we're going to move this point over one place to the left, because the opposite of 1 is negative 1. Negative 1 takes that to 0. Now we'll apply this negative 3 to that, because that has to do with the vertical placement. So here we are at negative 1, 0, and we'll subtract 3 from the y value 0, and we get negative 1, negative 3, and that's the vertex of the absolute value function we're going to graph. So we move this point over 1 and down 3. Now let's make a table, x and 3 times the absolute value of x plus 1 minus 3. And let's see, now we know the vertex is at negative 1. So let's pick two x coordinates, one on either side of negative 1, and one of those is 0, the other one's negative 2. So if x is 0, well, 0 plus 1 is 1. Absolute value of 1 is 1. 1 times 3 is 3. Minus 3 is 0. We already know that if x is negative 1, we get a negative 3 there. Now, let's replace x with negative 2. If x is negative 2, negative 2 plus 1 is negative 1. The absolute value of negative 1 is 1. 1 times 3 is 3. Minus 3 is 0. So we're going to graph these 2 points. And we're going to label them. There's 0, 0. And we'll go to negative 2, 0. Now, from the vertex, we'll run a ray through 0, 0. We'll run another one through negative 2, 0, and we have graphed our function. Well, we've labeled the intercepts. They're negative 2, 0, 0, 0. And now to state the domain, well, there's no possibility of division by 0, and there's no possibility of taking the square root of a negative number, so the domain is all reals, or negative infinity to infinity. As far as the range goes, the smallest y value that occurs in the graph is at negative 3, and all y values greater than that are also on the graph. So we're talking about the set y such that y is greater than or equal to negative 3. And let's see, we've graphed it, we've labeled the intercepts, and we've stated the domain and range, so we're done.